So we could talk about anything. We could talk about coasters. We could talk about nerdy engineering stuff, calculus, politics, religion, friends. All right, anybody got any nerdy jokes? Can't just vamp up here. Well, maybe I can. Let's find out. All right, I'm going to start telling dad jokes if nobody turns on something. You know, guy walks into a bar. Ouch. It was cold drawn too. Okay. This could be the longest live stream ever. Yeah, please, if you got any questions, put your question in the chat. I'll try to answer it. We'll have some fun. Shout out to one of my video guys, Mike Hummel. Right here. Made this cool, I don't know, whatever. It's aluminum casting made with arrow bees, the little ball thingies. That's pretty cool. So, thanks, Mike. You're the best. Let's see what else we got back here. Got me and my kids. That's me. That's my middle kid, Megan, and Samantha, and some random guy. We got to do the same stuff on Fury. That's pretty cool. Let's see. We got the logo. We got the oscilloscope. That's obligatory, man. Gotta have an oscilloscope. I don't know what I did without it. And yeah, everything. Got a full shelf. No questions, huh? Let's do some questions. What else can we talk about? We'll do trivia. This thing's gonna end up like some Babylon Bee skit where, you know, it's like 2 seconds of show and then an hour of credits. So I'd like to thank my wife, I'd like to thank my kids for helping me with this, for loving roller coasters as well, and helping me be that awesome nerd that I can be. Well, it's a start. Zauzedo. Did I say that right? What are you eating? Topology studies. I have never used a topology study, I guess formally. See what we get when we do a topology study. Noodles, nice. I'm not even sure what the qualitative study of shapes and spaces. Identify continuously deformed. Yeah, I'm at a loss here. I'm not sure why, what topology necessarily is. Topology 101. Kind of like this article. First thing he says is you gotta get precise definitions of what a planet or a sandwich is. And then you can ask, is Pluto a planet? Always good to get good definitions. You ask the stupid questions when you're working on a project. What do you mean by it needs to be lightweight? Lightweight for a bee. Or lightweight, just lighter than the competition. Donuts. Oh, SolidWorks, huh? I'm assuming that's some sort of add-on to simulation. No, I've never used that in the simulation. Oh, there it is. Yeah, that's pretty cool. And one of the things with topology is you gotta make sure that you consider all of your loading cases, because you can cut out some unwanted material if you're not careful. So, yeah, that is pretty cool. I've done stuff like this where you take this bracket and then you're like, well, I really need those material around those holes and obviously material around that hole, but I don't need all that material. Done that. Make some cool designs from that too. All right. Frequency and impact force. Ooh, that's a good question. Yeah, so generally speaking, the stuff that I've designed does not do much with impact force. If there are, what am I doing here? If there are loads, it will be somewhat non-impact, or the system will have enough sponginess in them to dissipate a lot of that energy by the time. So I'm not really doing with impact. Analysis-wise, it's all empirical. So one of the things we used to do was design fiberglass components, and the fiberglass components, we would just drop weights on them and see what kind of force it took to puncture them, and we'd make design improvements based on that. Other than that, not much as far as impact analysis. The other question was frequency. Yeah, frequency. Once again, another impact or empirical thing where we build whatever we're trying to do, and then we had a lot of times dealing with mobile equipment. We would have just a road testing fixture that would simulate going over bumps and going on different types of roads, gravel roads, highways, different scenarios. And we would simulate that on a fixture and just shake it to death and see what would happen. We did get a lot of information. I'm not going to divulge any of that of what kind of design factors we should use, and how we actually did some FEA runs as a result of that, using some of that data. So we found out with some cases just the rotating vibration needed a 6-to-1 design factor in certain cases, depending on what it was being used at. Oh, there's a connection problem on my side, huh? Let me go check that out. Am I still having issues? This shows me as being refreshed. Anyway, for fatigue loads, generally we were able to use classical fatigue or weldment fatigue analysis. Weldment fatigue is very interesting. Basically, depending on the type of weld you have, it falls into different buckets. Hey, good plug here for my Design of Weldments course. If you actually do some designing of weldments, you probably want to sign up for that course. You go to mentoredengineer.com/weldment. That will get you into my class. Next one starts March 20th, and it is fantastic as far as learning what you need to know about designing weldments. Right, so here's the article here. Learn a lot. Need to understand how to communicate or understand welds and communicating them. Designing for fatigue, the big part of the course. Weld distortion, man, that's a pain in everybody's head, because this happens right here. You got nice T joint, and then all of a sudden it becomes the tau symbol. So properly designing joints. That's one of my favorite parts of the course, because there's a lot that goes into designing a good weld joint. And a lot of times you can put a lot of weld on there, you can put the right welds, but if the stress is flowing through it wrong, you're just going to have a bad design. Something like this, you got these really high stresses, you can never get rid of them. Designing for manufacturing, there's a lot that goes in there, and that's when your design hits, is your design going to be profitable or not? So, recommend the course. Hey Jay, yeah, I have a mechanical engineering background. Most of my experience is in the mobile equipment industry, specifically dealing with electric utility transmission and distribution. These would be insulated aerial lifts mostly. Also done some work on things like underground line pullers, off-roading vehicles. Let's see what else. Done some industrial automation as well. Not too much though. All right. Ooh. So getting into the roller coaster, I did that during 2020. I didn't have any clients at the time, and I just thought it would be fun. I tried it many years ago when I was in grade school, and that one didn't turn out so well. Luckily, nobody got seriously injured. And just wanted to take a stab at it, see what would happen. And it's been fun. I've always loved coasters. In fact, I've already been this year in the middle of winter, which was fun. It's cold on those rides when you're going 90 miles an hour. So yeah, that's it's kind of a challenge accepted type of thing. Laser welding. Not exactly sure what laser welding necessarily is. Let's open that up. I thought lasers were more for cutting. I didn't know you could weld with them. Super laser cold welding machine. What is laser welding? Okay. So back in, I guess 2 jobs ago, we were doing some friction welding, which is very similar, it sounds, to this, on plastics. And yeah, I guess you can melt plastics real quick with a laser beam, and then I guess it melts a little bit and then falls into itself. That's pretty cool. Don't have any experience with it. I imagine it's a very intense process that you need, just like any welding, you need some sort of qualified person to be doing that. So could be the future, who knows? Hey, thanks for the question. Now, the interesting thing here, they got this remote laser welding of aluminum. I will say, just with aluminum, anytime you're welding, it's not a great bond. Well, the bond might be okay, but aluminum gets its strength from its temper. So whatever you weld pretty much has to be retempered, and make sure that you're using the right type of tempering process for that. Thermal structures. Possibly. So AJ, yeah, I'm looking thermal structures. I'd like to at least take a look at it. I'm not sure what you mean necessarily by thermal structures, but if you want to schedule some time with me, go to rasmussendesigns.net, and that's where my engineering company is. And I believe, go down here, you can schedule a consult with me, and we can pick a few minutes here to chat. That's not the one I want. That's not it. That's not it. I think it's back here at the Mentored Engineer. Right. I think it's this one. Schedule a meeting. Interest meeting. We have a 20-minute meeting. So if you go down to Mentored Engineer, the homepage, scroll to the bottom. Now, I've done thermal studies in the past. I don't know if I haven't done it in probably 15 years, so may not be the right person. May just be able to give you a little tidbit of advice when we get into your specific problem. Good questions, good questions. Bet you in about 5 minutes I'm going to get an email with the time, right? What do you mean by treatment of welds? Is that for like protection from corrosion, or is that some sort of tempering? I've never did anything structural with stainless steel. The closest I've come is we had some stainless steel pins that had a lug welded on it to prevent it from rotating, but the lug itself was not structural in nature. Yeah, stainless steel is not one of my favorite places to weld, just because there's so many things that can go wrong. Uh, Actually, those pins that we were making and putting the lugs on, they actually welded them with some regular steel welding rod, and came up and he was the welder was still using his MIG welder. And I'm like, oh, you changed out the wire fast. And he looked at me like, what? And yeah, he had welded them with the incorrect wire, so those welds would have rusted fairly quickly. Yeah, the 316 stainless steel is fairly common. It's probably one of the most common types of stainless steel. Very good corrosion resistance. Fairly strong. I just don't like welding it. That's all. I don't design enough stuff that needs to be that corrosion resistance that is weldable. Good questions. Yep, pharmaceuticals and food. It's one industry I've never gotten into. And it's funny because where I live is kind of it's Durham, North Carolina, the city of medicine. And there are lots of places that do all sorts of medical research and whatnot. So there'd be lots of jobs if I was in that field, but I'm not. I'll stick to making roller coasters and designing awesome structures. Do I double check my simulation with calculations? Absolutely not. I do the calculations first. That's one of my big points. Always do the calculations first. It'll save you so much time. You don't think it will, but when you get to FEA is a very slow process. I've spent weeks doing, trying to make small changes when I had a big problem. And it wasn't something I could necessarily work around the edge or try to, I got to add a little bit here, make this weld a little bit bigger. I had serious structural defects. So, no, I double check my calculations with simulation, with FEA. And part of that is especially since I do a lot of weldments, knowing good joints versus bad joints and starting with a good design and knowing that where I'm putting my material is going to give me the best benefit. And then knowing when and where I do need to do FEA just based on the structures that I'm designing. Once again, go to mentoredengineer.com/weldments. You can learn more there. You can sign up for the class. Class starts March 20th. All right, then. Well, thanks for joining us here. And hey, you can learn more at mentoredengineer.com. And be sure to check out the rest of the YouTube channel. Got a lot of stuff. If you like roller coasters and nerdy stuff, it's all there for you. So thank you and have a wonderful day.